Okay, so with regards to covalent bonding, the important terms are electrons are shared between atoms. Covalent bonding also occurs between non-metals. So when a non-metal atom bonds with another non-metal, then we're going to find that there is a covalent bond. Okay, now your textbook might have a little table in it to explain when a bond is ionic and when it is covalent. So let's look at, for instance, a bond between carbon and oxygen. You have a periodic table with you.
Yes, sir.
Okay, look at the electron negativity of the carbon atom. I think on your table it should be 2,5.
Yes.
So the electron negativity of that carbon is 2.5, isn't it? And the oxygen, it should be 3,5. Can you see those values?
Yes.
Yes, sir.
Okay. Now, you might have a table saying the following. It's not very accurate. None of the textbooks are really very accurate. But you can keep that as a reference. I'm just going to paste the table I've got in my book. So basically it boils down to the following. If your electron negativity, let's look at the top one. If the difference, that delta means difference. If the difference in electron negativity is bigger than 1 and smaller than 2.1, then that is ionic. If it's between 0 and 0,4, it's covalent or non-polar covalent. And if it's between 0,4 and 1, it's polar covalent. Do you have that in your textbook?
I'm sure we do, but I'm quickly just having
Your values might slightly differ. You might have a 0.9 here. There's difference. It's not fixed values. It's just the indication of when is something. When a bond is polar or non-polar, covalent polar or covalent non-polar, or ionic. Don't worry about that now. Okay. So for us to do some covalent bonds, you need to be able to do Lewis structures. Have you done any Lewis structures?
No.
Okay, Lewis and Cooper structures. This is just to show you how this bond forms. So let's start with some easy ones. Okay, let's look at chlorine gas, Cl2. Okay, we need to be able to draw Lewis structures of that to basically explain how this covalent bond forms. So there's 2 chlorine atoms, 1, 2. Okay, now go and find chlorine on the periodic table and tell me what group number it is. Hello, it's group 7. That you should know off by heart.
Okay, sir.
Anyone? Is that right?
Yes.
Yes, sir.
Okay, so how many valence electrons does chlorine have?
3.0.
Just hold a second.
I know.
Can you hear me now?
Yes, sir.
Sorry about that. Sorry about that. Okay, good. So we found chlorine in group 7. Is that correct?
Yes.
Each one of those atoms got 7 valence electrons. So for a bond to take place, I need to take one of the electron of each of these chlorines and share it. So the chlorine on the left-hand side, I've used one of his electrons to share a bond. And that means there's 1, 2, 3, 4, 5, 6 left. So those 7 X's belongs to the chlorine on the left, and those are the 7 valence electrons. One is used for sharing. And then there's another chlorine atom, and that's also got 7 valence electrons. One is used for the bond, and so 6 remain. And that is called a Lewis structure. So this is a Lewis structure. Have you done any of this work?
No, not yet.
Okay. And a Cooper structure is the same, but in a Cooper structure, we only draw a line that represents the bond. So this is a Cooper structure. You are allowed to still draw in valence electrons, 1, 2, 3, 4, 5, 6 that remain. 1, 2, 3, 4, 5, 6 that remain. So you can draw the Cooper structure like that, or you can just draw it like that. And you see that that line between the chlorine atoms now represents the bond that has occurred because of the sharing of those 2 electrons. So for an atom to be stable, it has to be surrounded by 8 electrons. Look at this chlorine, it's surrounded by 8 electrons. Also, the other chlorine is surrounded by 8 electrons. So this is a covalent bond, okay? Why? Because electrons are shared between the 2 atoms. So tell me, what is the difference in electronegativity? What is the electronegativity of chlorine? Is it 3.0 or 3.0?
Yes, 3.0.
So the one is 3.0 minus the other one is 3.0, and that difference in electronegativity is 0. Obviously, it's 0 because the 2 atoms are exactly the same. So this is a non-polar covalent bond. Do you understand that? Why?
Yes.
The difference in electronegativity is smaller than 0.4. Okay, good. Let's draw another one. We're going to draw a couple of, these are very important. What you also can do is just study the structures in your book. Your textbook's got a couple in there, and you in grade 10, you're not going to really find any ones outside the textbook. So let's do a bond between hydrogen and chlorine. Can anyone tell me if this bond is going to be ionic or covalent? Just a cheap, easy way to find out if it's ionic is or covalent. A covalent bond, we're going to have a non-metal bonding to a non-metal. Are those 2 non-metals? Is hydrogen and chlorine both non-metals? Yes.
Yes, I am.
So it's going to be a covalent bond.
Okay.
If there's a metal bonded to a non-metal, it's ionic bond. Okay, let's ask ourselves. Okay, how many valence electrons does hydrogen have? What group is hydrogen? Come.
Hydrogen is in group 3.
No.
3, wait. No. It's in
Group 1.
group, yes,
The
group
first
1.
element. So it's got 1 valence electron. And chlorine, group 7. So it's got 1, 2, 3, 4, 5, 6, 7 valence electrons. So there's the bond. The bond takes place when these 2 electrons are shared. So each element donates 1 electron to share for the covalent bond to take place. Okay, good. And hydrogen is an exception. Hydrogen is not going to have 8 electrons around it, but chlorine does have to have 8 electrons around it. Why is that? Because of the what? Aufbau diagram. In the Aufbau diagram, there's space in the chlorine atom for more electrons. In the Aufbau diagram on the hydrogen, there's only space for 1 extra electron. So your hydrogen 1s orbital can now have 2 electrons in it. Well, chlorine's got a lot of electrons left. It can add electrons. Chlorine's got 1 extra space left for electron, so it can add another electron. If you draw off-bow diagrams of that, you'll see. Okay, now I want to know if this is polar or non-polar. What is the difference in electronegativity? Chlorine is what? 3.0. Minus, what is hydrogen?
2.1.
2.1. So the difference is 0.9. So that means it is polar covalent. Covalence with a C. I don't know why I'm doing K all the time. Covalent. Let me just fix this. I think I wrote it with a K. Yeah. There we go. Covalent bonding. Okay. Right. Are you in your textbook on the page where you have Lewis diagrams? Not. Okay, let's do some more. I'm going to do oxygen gas. Now, this is important one, very important one. I'm just going to go through the ones that are important. So there's one oxygen atom and there's the other oxygen atom. Right. Give me the group number in which oxygen is. Group number what? Okay, we are busy with the oxygen
Oxygen atom. Okay.
oxygen gas. So oxygen gas contains 2 oxygen atoms, like that molecule. Oxygen is in what group number in the periodic table? Quick. 6.
In group 6.
So I've got 6 valence electrons around each oxygen to put in. So 1, 2, 3, 4, 5, 6. And then this oxygen is donating 1 for the bond, 2, 3, 4, 5, 6. But look here, very important. If you look at the electrons surrounding that oxygen, how many electrons around that oxygen? There's only 7. Can you see that? It's sharing 1 electron with the oxygen on the right, but the one oxygen on the left only got 7 electrons around it. And so does the one on the right only have 7 electrons around it. So that's not cool. It needs to have 8 electrons around it. It's called the octet rule. So then what you do, if you haven't seen this, you must give attention now. Take one of these electrons and you move it in towards the bond. And I take this electron and I move it towards the bonding area there. So now they are sharing two pairs of electrons. That means there's a double bond. So this is my Lewis diagram. And my Cooper diagram will look like this. There's a double bond. There's 2 pairs of electrons that are shared. Now each one of them is surrounded with 8 electrons. Look, that oxygen has got 8 electrons around it, 2, 4, 6, 8. And this oxygen's got 8 electrons around it. So that's called the octet rule. So all of those atoms except hydrogen and boron. And there's also exceptions with phosphor and sulfur, but I'll get to those. All of the other nonmetals want 8 electrons around them. The reason hydrogen is an exception because hydrogen only has an s orbital to fill, so it can only have 2 electrons around it, the nucleus. And boron is in group 3, which means it can only have what? Give 1 electron away. But we'll get to boron. It's kind of difficult, and I don't even think you do it in grade 10. So this is a very important one. The oxygen you're going to study. The other important one is water. Let's get to the water molecule. Water is called H2O. It means that there's an oxygen that's bonded to 2 hydrogen atoms. Okay, let's draw that. So I've got an oxygen in the middle. Now, very important, you must look at this. Then there's two hydrogens. You must learn that the hydrogens you're not allowed to draw like that. This is one that you have to learn. The hydrogens are at an angle. So I'm going to take oxygen. Let's start with oxygen. Oxygen is going to donate 1 electron to share. And then it's got six electrons, so it's got 4 left. 1, 2, 3, 4. And the hydrogen only has 1 electron, so it's donating that electron to share. And that's the Lewis diagram. This is a funny Lewis diagram. Okay, you're not allowed to draw it like this. So this one you're going to learn. You're not allowed to draw it linear, like in one line. It must be at an angle. And you're going to learn that angle is about 104 degrees. It's in your theory. So this is my Lewis diagram for water. That's my Cooper diagram. And you are allowed to draw those electrons in like that. Okay, this doesn't make a lot of sense, but you have to study this one. There's a couple of them that you have to study. You have to know what the structure looks like. We'll only do that next year to understand why it's at an angle. So water is one that you have to learn. Oxygen is one you have to learn. The next one is nitrogen. Okay, look at this. This is the one you get often. There's one nitrogen atom. There's another one. Group what? Quickly find nitrogen on your periodic table.
Nitrogen is in group 5.
So it's 5 electrons. 1,
5.
2, 3, 4, 5. And then the other nitrogen, it's got 1 electron. 2, 3.
Okay, but Sean, why is it only 5 electrons and not
It's
7?
no. Yeah, you're right. Okay, look at this. Let's quickly draw a off-power diagram of nitrogen. So there's the first energy field, and that's the 1s orbital. And then nitrogen is in period 2, so it's got 2 energy fields. There's my 2s orbital, and there is my 2p orbitals. Okay, you're right. Nitrogen's got 7 electrons. 1, 2, 3, 4, 5, 6, 7. Is that correct?
Yes.
Yeah. But these electrons that are bonding in my Lewis diagrams are only my valence electrons. It's only the electrons in the outer shell that is actually partaking in the bond. In other words, these electrons in energy field number 1, they're not partaking in that covalent bond. It's only the electrons in the second energy field or the last energy field that does partake in bonding. Okay. So there's actually only 1, 2, 3, 4, 5 electrons at the outside or the highest energy field, and they are the ones partaking in a covalent bond. So that's why we say, what group number is nitrogen? It's in group 5, so there's only 5 valence electrons. If you look at phosphor, just below nitrogen, phosphor has got 15 electrons. You see that? Phosphorus, 15 electrons. But there's also only 7 electrons that partake in the bond because phosphor is also in group 7. So look at this. Look at this. I'm going to keep this off-power diagram. I'm going to keep it. I'm trying to get that yellow gone. Okay. So look at this Lewis diagram I'm going to be doing here on top. So how many electrons does this nitrogen have around it now? 6. You see that? Speak to me, Saskia. Is there 6 electrons around that nitrogen?
Yes,
okay, so it's wrong. There needs to be 8. So I'm going to move one of these electrons to the center again. I'm taking that electron and putting it down there. So it disappears over here. How many electrons around the nitrogen now? 2, 4, 6. Wrong. So I'm taking this electron also to that center pit. So how many electrons now around this nitrogen? 2, 4, 6, 7. Still not 8. So I'm taking another electron. Taking another third electron. And I'm also moving that electron. So there's a triple bond. So it basically looks like this. There's my one nitrogen. And then there's triple bonds. 3 electrons. And then I have 2 electrons here and 2 electrons there. So that's our Cooper diagram. Sorry, this is my Lewis diagram. And my Cooper diagram will look like this. Okay. But let's go to this Aufbau diagram to explain it. I'm just going to move this Aufbau diagram. So there is the one nitrogen atom. And there's the other one. Let me just make this slightly smaller so I have another bit more space. So there's the one nitrogen atom, and there's the other nitrogen atom. Can you see how many electron spaces we have in both of them? So if they overlap, then these 3 orbitals here can each one get that electron or share that electron. Those 3p orbitals, they can actually share electrons because there's space in each of those orbitals, there's space for one more electron. And that's why we have a triple bond there, because there's 3 electrons sharing. These 2 electrons are going to share in one orbital. Those 2 are going to share in one orbital. And this one and that one's going to share in one orbital. Does that make sense? Sort of.
Yes, sir.
Yeah. Okay, the last important one that you have to learn is NH3. What's that called? What is NH3?
Nitrogen high.
Yeah, well, you can say nitrogen trihydrate, but it's called ammonia.
Okay.
Okay, that's ammonia. There's also ammonium. NH4 plus is ammonium. Okay, that's ammonia. Now, ammonium we're going to also do, but let's just take that away for now. Right, so we have a nitrogen atom, and we have 3 hydrogen atoms. Okay, very important. How many electrons do we have, or how many valence electrons do we have at the nitrogen? It's 5, isn't it? And the hydrogen, 1 times 3, this is 3 hydrogens. Okay, let's put in electrons that can share. 1 from the nitrogen, 1 from the hydrogen. 1 from the nitrogen, 1 from the hydrogen. 1 electron from the nitrogen, 1 from the hydrogen. So the hydrogens are all used up, but from the nitrogen, I've only used 3 electrons, so there's 2 left. 1, 2. So now that ammonia, it's got 8 electrons around it.
So you don't add the extra 2.
We have added the extra 2. Count the circles around the ammonia. Can you count? There's 5.
Oh, yes, there is. Okay.
But there isn't another hydrogen to bond to that. So this is your Lewis structure for ammonia, and your Cooper structure will look like this. This is your Cooper structure. Okay. You'll find ammonia also in your textbook as one of the ones that you have to learn. Now, there's a specific covalent bond that is very important. We're going to do that quickly. So these are the last 2 ones. The one is NH4 plus, which is ammonium. And there is H3O plus, which is called hydronium. Okay. These are called dative covalent bonds. We're going to be tested on this. Dative covalent bond. So what happens is the following. let's use ammonium as an example first. We have the NH3 molecule. There's its Lewis diagram. Just draw that. Then we're going to add a hydrogen ion. A hydrogen ion doesn't have any electrons. So that hydrogen ion is positive. Well, these two electrons on top there is negative. So that hydrogen ion is going to be attracted to that negative electrons there. They are not bounded, they're unbound. And then it's going to stuck there onto that negative side of the molecule. There's the hydrogen ion. So this one here is that one there, 3. And that's going to make this whole molecule +1. And this is called dative covalent bonds for the simple reason that that bond there between this bond here between the hydrogen and the nitrogen is the electrons that are shared is only supplied by one atom, which is the nitrogen. And that's why it's called dative covalent bond. Okay, do you understand that? Okay. Now we also have water here. Hydrogen bonded to oxygen. I'm going to do a Cooper's diagram of this. And then the same thing happens when we have a hydrogen ion, not an atom, an ion. It doesn't have any electrons. It goes and bonds to that pair of electrons there. And this is also dative covalent. And that hydrogen goes and sticks there and makes the whole molecule +1. So we have H3O plus, and we have NH4 plus. And those are two dative covalent bonds. It's very important. You are tested in grade 10. You are always tested on this. What is dative covalent bond? And write a little formula to show us. This you must know. Okay, this sums up covalent bonding. So in covalent bonding, you need to be able to give a definition. You need to say whether the bond is covalent polar or non-polar by looking at the difference in electronegativity. And then you have to draw Lewis diagrams. And then you have to do these two dative covalent Lewis diagrams. Okay, ionic bonding. Okay, the key words are the following. Electrons are transferred between ions. Or between atoms, basically. Let's make that atoms. The ions afterwards, atoms. Okay, and this bond happens between a metal plus a non-metal. And your Lewis diagrams, they look totally different. Okay, now you have to be very careful. If you get this wrong, you're in trouble. So let's do the following. I mean, you have done a lot of ionic bonding already. So if I tell you what is that? That's sodium chloride. No, it's like table salt. How does that bond form? Okay, it's an ionic bond. Why? Well, you can go and have a look at the difference between electronegativity if you want to. It's going to be way more than 2. But you can also say that's a metal, and that's a non-metal. So how do they bond? Well, you learned it the following way. You said that sodium has a charge of +1 because it's group 1, and chlorine is in group 7, so it's a -1 charge. So those bond very easily. But in your Lewis diagrams for ionic bonds, you need to be able to write it in 3 steps. So the first step, step 1, is when we take our metal with its single valence electron, because sodium is in group 1, so it's got 1 valence electron, and then it gives that electron away. So the sodium becomes 1+ by giving a single electron away. That's your first step. So that becomes a Na+ ion. It loses the electron. In step 2, the chlorine, which is the non-metal, that has got 7 valence electrons. it picks up that electron. So that electron basically is picked up by or stolen by the chlorine atom. And then we have, look at this. We have Cl, and now I'm gonna let me add that electron in another area. So we have plus plus, there's all its valence electrons. And then that single electron, that dot I'm making now, so chlorine's got an L. That dot there is the electron it picked up. And so this becomes -1. What's shifting around there? And then step 3, I add these ions, the Na plus and the chlorine. Negative. Those two ions attract one another. One is positive, the other one is negative. And that becomes sodium chloride. That's 3-step method for what? Sodium chloride. You need to screenshot that, or you'll have that in your textbook as well. But this you need to be able to write. This is 3 marks.
Okay.
Let's do 2 more. Okay. So what I want you to do before we start, I want you to write a formula for magnesium bromide. Magnesium bromide. Quickly write a formula for me for magnesium bromide. Quickly do that. Okay, help me. Mg, what?
Mg with a positive power, positive 2.
No, it's a negative.
Okay, what's the result? MgBr2. Do you have that?
Yes.
Okay, good. Let's see. Let's draw a Lewis diagram of this ionic bond. Okay, so step 1, remember, because it's a metal and a non-metal, I'm going to do 3 steps. So magnesium is in group 2. It's got 2 valence electrons. And it gives those 2 electrons away. It gives it away, and therefore it becomes 2 plus. That's step 1. Is that easy? Yes. Okay, it's got 2 valence electrons. We'll give 2 electrons away and means it becomes 2 plus. And then bromide, Br, it's got 7 valence electrons. And it will pick up 1. Become what? Br, 1, 2, 3, 4, 5, 6. There's its 7 electrons, and it picks up 1 electron. So it becomes Br 1 minus. But I can't let these 2 react with one another because magnesium is 2 plus and Br is only 1 minus. So I need to do the following. I need to multiply the bottom equation by 2. And then I get 2 here, 2 there, 2 there. You see that?
Yes.
Okay. Right. Therefore, in step 3, magnesium 2 plus will bond with 2 of those bromine ions. I have to put in all the electrons. It's really a lot of work. And then I'll get Mg Br2. So there's your result. But in this Lewis diagram, I have to explain how it happens. Okay, now I'm going to make you do one. And it's a difficult one. I want you to write a Lewis diagram or Lewis diagram structure. Aluminium oxide. Okay, before you do that, can anyone write aluminium oxide without doing those 3 steps? What is aluminium? Let's just get the answer first. Aluminium is in group what?
Aluminium is in group 3.
So it's 3 plus.
Yes.
In oxygen?
Oxygen is in group 6.
Charge, please.
Charge will be -2.
Very good. So what's the result?
So it will be AlO3.
Nope. Al2O3.
AlO2, okay.
2 of those gives me +6 and 3 of the -2 give me -6. Remember, there's a cheat if you struggle. You put the 3 there and you put that value there.
Okay.
Okay, now Ghost, I want you to write step 1, 2, and 3. Try that.
Okay.
Go. We have a minute left. If you don't know how to balance it, it's fine. I'll show you. You haven't done a lot of these, so I can't really expect you to do this one. Are you back?
Yeah, sure. Our signal's really bad.
Okay,
Yeah.
let's do it together.
Okay.
Step 1 is the metal. That's aluminium. It's in group 3.
Okay.
So there's 3 valence electrons. 1, 2, 3. It's going to give those electrons away. So after it's given 3 electrons away, it becomes 3 plus. Good. Step 2 is the non-metal, oxygen. Oxygen is in group 6. So there are 6 electrons or valence electrons. It will be able to get 2 more. How do we know it's able to get 2 more? Because 2 more means it piles up to 8 electrons, and it can take 8 electrons in its outer shell. How do I get those 8? Well, an s orbital takes 2, and those 3p orbitals take 2. So that's 8 electrons. So that picks up 2 electrons. Okay, I'm going to draw that. There's his original electrons, the 6, and then it gets 2 more. And then its charge becomes 2 minus. So that's perfect, actually fine. You knew that right from the start, that aluminium will become 3 plus and oxygen will become 2 minus. But now we have to balance these electrons. In other words, this 3 electrons here and those 2 electrons must be the same value. So I'm just going to multiply the one with 2 and the other one with 3. So then I have 2, 2, 6, isn't it?
Yes.
And then I have 3, 6, 3. So now step 3, the 2 aluminium 3 pluses is going to join with the 3 oxygens, that's 2 minus. You have to put in all the little dots there. And that becomes Al2O3. Look, this is a lot of marks, 3 marks for just writing those things, and you can do it already. Okay, so how do we differentiate between covalent and ionic bonding? Ionic bonding is a metal connected with a non-metal, and covalent bonds are non-metals only. Let's do one of these Lewis diagrams. One more. This one you're going to do on your own.
Okay.
You're going to do, let's say, calcium oxide. We've just done oxide. Calcium oxide. Go. 3 steps. 1, 2, 3. How do I know it's 3 steps? Well, it's a metal and a non-metal. Go. What you can do is do the result first, and then you do the 3 steps. At least you know what it's going to look like.
Okay.
Tell me when you're finished.
Okay. I've lost myself. I'm confused.
Okay. Right. Calcium is 2 plus, isn't it? And oxygen is 2 minus. So it's just
Yes.
CaO. Okay, good. Let's start. Which one is the metal? Calcium or oxide? Oxygen.
Calcium.
Okay, good.
No.
So it's Ca. It's got group 2. So it's got 2 valence electrons. That's correct. So that it gives those 2 electrons away and it becomes 2 plus. Are you happy with that?
Yes.
Okay, now the non-metal is oxygen. It's in group 6. So it's got 6 electrons. Yeah. It will take up 2 electrons. And then it would become oxygen with 8 electrons around it. I'm just going to practice this. It's going to make... and then its charge is going to be 2 minus.
Okay.
Now these two, they bond perfectly with one another. So there's no balancing needed. So it's just Ca2 plus. I'm going to add the oxygen to that ion. You have to like put in all the dots. There must be 8 of them. That becomes CaO. It's not difficult.
Okay. Thank you.
All right. I want you to do the following on your own. I want you to draw a Lewis diagram for water and one for CO2 quickly. See if you can remember what I taught you. Lewis diagram for water and one for CO2. The first thing you want to ask yourself, is it just a Lewis diagram or is there 3 steps?
Okay.
Can you answer that?
Well, the first one will be a Lewis diagram with 3 steps.
3 steps.
Um,
Where's your metal?
no, there's no metal, sorry.
And in
Carbon,
CO2, there's no metal either.
yeah. So it'll only be a Lewis structure.
Yeah, only the covalent Lewis structure.
Okay.
Quickly that, then we're finished. These are 2 ones that I want you to learn. You don't need to understand them yet. Just learn them. Okay, so the one looks like this. Oxygen. Water. Hydrogen, sorry, not water. Is that the one? That's the Lewis diagram. The Cooper diagram will look like this. And then CO2. There's my Cooper diagram.
Yeah.
And the Lewis diagram will look like this. Oops. Oxygen. And then there's 2 electrons here.
Okay.
That's Lewis. Okay. Next week we start with pulses and waves and stuff. Okay. You have to do some work. Not doing enough work. You must complete all the work in your textbook. You must complete all the sums.
Okay.
Bye-bye.
Thank you, Shaw.
Pleasure. Bye.
Have a nice day.